All right, Algebra 1, Unit 3, Target D, Graphing Linear Inequalities, the notes. All right, so example 1 says graph the following inequalities. Now, a majority of these equations that we see are going to be in slope-intercept form, which means y equals mx plus b. The main difference is this chart in the bottom corner. Because we have inequality symbols, we're going to have either a solid or dashed line, and then we're going to have to either shade above or below. Okay. So first thing I would do would be right above, write down y equals mx plus b. Okay. And then from there, we graph linear inequalities by starting with the y-intercept first. So the b is the y-intercept. In this case, it is -5. So on the y-axis, I'm going to look for -5, which is right here. And we can put our points. Next thing we're going to be wanting to look at is our slope. Okay, we have a +3/5. The 3 in the numerator tells me to go up 3, and the +5 in the denominator tells me to go to the right. So from my y-intercept, I'm going to go up 1, 2, 3, and then 5 to the right, puts me right here. There's no more space in either direction for more points, so that's good enough. Based on this symbol right here, I'm going to want to use, right here, matches up right there. We're going to use a solid line, so I can connect my 2 points with a solid line. Make sure to put arrows at both ends. And then according to this, we're going to want to shade below. So what that means, this says y is less than or equal to the line. So we want everything beneath. I look at the y-intercept -5. I ask myself what y value is less than -5. That would be -6, which is located below. So I'm going to go ahead and shade everything below. Okay. I'm just going to use lines to sort of indicate just so that you can clearly see. Now, keep in mind, any point in this shaded region, also known as a solution region, would be a solution to this inequality. Okay, so some possible examples. First things first, let's put down here, we use a solid line, and we shaded below. Okay, and then right here, we'll just put some possible solutions. So let's see, this point right here, 4, -5 would be a possible solution, which means I can plug in x, the x value 4, and the y value -5 back into this inequality, and I would get a true statement. Another possible solution would be this one, which is 2, -5. Keep in mind, points on the line would also be a solution because it's solid. So like the point 5, -2, even though it's right here on the actual line because the line is solid, we would also consider that a solution. Okay. And then things that are not solutions would be anything that's not in the shaded region. All right, the next one. We have y is greater than -2/3 x plus 4. Again, start by identifying that the solution is in mx plus b format, which means slope-intercept. I'm going to start with the b, which is our y-intercept. And in this equation, it's a +4. So on the y-axis, we're looking for +4. It's right here. Draw our point, our y-intercept. Then let's use our slope to find more points. Our particular slope here is -2/3, so we can toss that negative to the top or to the bottom. I'm just going to go ahead and put it to the top. So then the 2 in the numerator is negative, telling me to go down 2, and the 3 in the denominator is positive, telling me to go to the right. So from my y-intercept, we're going to go down 2 to the right 3, which puts this point right here. I could keep following the pattern, down 2, right 3. It looks like I can fit one more point in the opposite direction. So from the y-intercept, instead of going down 2, I'm going to go up 2. Instead of going to the right 3, I'm going to go left 3, which gives me that other point right there. Okay, now based on this inequality symbol, we're looking at this scenario. So we want to use a dashed line. Okay. So let's go ahead and connect the points real quickly. we're going to shade above. Okay, so the inequality symbol says y is greater than. So I look at the y-intercept 4, and I ask myself what y values are greater than 4, 5, and 6, which are located above. So I would shade everything above this line. Okay, so then let's just talk about some possible solutions. There are infinitely many, but just to label a few, let's see this point right here, 4, 2 would be a possible solution. This one right here, which is 0, 5. And one more possible solution would be 5, 5. Keep in mind, as long as they're in the shaded region, they're a solution. This time around, points on the line would not be a solution because the line is dashed, which means we don't want to include those. All right. C. We have y is greater than or equal to negative 2x plus 3. Again, start by identifying that it is in slope-intercept form. Start with our y-intercept, which is b. In this particular equation, our y-intercept is 3. So again, going to the y-axis, looking for the positive value 3. That gives us our first point. Then you want to go with m, which is your slope. This time around, slope is a whole number. It's an integer, negative 2 actually. We want to write that as a fraction because we want to be able to determine which direction. So the negative 2 on top tells us to go down. The positive 1 on the bottom tells us to go to the right. So from the y-intercept, we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. It looks like we can put one more point in the opposite direction. So from the y-intercept, instead of going down 2, up 2, and instead of going to the right 1, left 1. All right, now looking at the inequality symbol, looks like we're looking at this case right here. We're going to have a solid line. So we can go ahead and connect the points. Arrows in both directions. It tells us to shade above. So again, looking at your y-intercept is 3. You ask yourself, what y value is greater than 3? 4 and 5, which is located above. So we're going to shade everything above the line. And that represents possible solutions. So let's list a few. Let's see, 3, 0 would be a possible point. We have 5, negative 3 would be a possible solution. 2, 6 would be a possible solution as well. Notice any points on the line would also be a solution because the line is solid. All right, the next one we have is y is greater than or equal to negative 3. So even though it may not seem like it, this equation is actually in y equals mx plus b format. All right, we still have a b, which is our y-intercept. It's going to be at negative 3. So on the y-axis, negative 3 would be right here. Okay. Now, when it comes to slope, there is no mx, which tells us that there is 0 slope. If there's 0 slope, that means there's no slant. That means we're looking at a horizontal line. And according to this symbol, we're looking at this one right here. So solid line. Okay, solid and horizontal. Okay, and then we're going to shade above. So notice it's y is greater than negative 3. So you look at the y-intercept negative 3. You ask yourself what values are greater than negative 3, negative 2, negative 1, everything above. So we shade everything above that line. So the origin would be one possible solution. 5, 2 would be a possible solution. -4, -2 would be a possible solution. These are just three possible solutions. There are an infinite amount of them. Any point on the actual line in this case would also be a solution because the line is solid. All right, the next one, E is y is less than 2. Okay, so again, this one is like before and y equals mx plus b. Okay, b is our y-intercept, which is +2. So on the y-axis, +2 is right there. And then for m, our slope, there is none, so we say it's 0. So that tells me that's going to be a horizontal line again. Okay, and it looks like we're looking at this scenario right here. It's going to be a dashed line. And we're going to shade below. So if you think about it, the inequality is telling you that y is less than 2. So y value is less than 2 would be 1, 0, and anything negative, which is located below. Okay, so not the best shading, but a little bit limited here. So, all right, and then possible solutions. Anything below that, so we would have, let's say, 0, -5, this point right here. Another one would be 4, 1. Another one would be -5, -2. And again, there are an infinite amount. All right, example 2. A, graph the following inequalities. Now it's a little bit different. These are not in y equals mx plus b format. These are just x and some constant. So hopefully we remember that tells us that what we have are vertical lines. And it looks like we have this scenario. Okay, so we know it's going to be a vertical line. It's going to be dashed. So because it's x, we're looking at the x-axis. Now we're looking for -2, which is right here. It's going to be a vertical dashed line. So something like this. According to this, we're going to shade to the right. And that makes sense because it says x is greater than -2. So if you look at the x-axis, we want values greater than -2, -1, 0, all the positive ones, which is going to be everything to the right. Okay, so possible solutions. Let's see. The origin would be 1, 0, 0. 4, -3 would be a possible solution. 3, 6 would be a possible solution. Any point on the line would not be a solution because it's dashed, which means it's not included. All right, B, similar. We we have x and some constants, some numbers, so that tells us that it's going to be a vertical line. Okay, and we're looking at this one right here. Because of the inequality symbol, it's going to be solid. It has that equal sign underneath it. So we're looking at the x-axis for +1, which is right here. It's going to be a solid vertical line. Draw my line, draw my arrows, and we're going to shade to the left, which makes sense because the way you would read it is x is less than or equal to 1. So we look at values less than 1, which would be 0, anything that's negative. So on the x-axis, that's everything to the left of that line. All right, so possible solutions. Let's see, you have -4, 0. You have -3, 5. Another possible solution would be -1, -4. And so forth and so forth. Okay, that's it for notes for target 3D. Go ahead and try the practice in the packet.